Hello and welcome to Cloud Tech 10 for the 7th of August 2017. I'm Mark and I'm going to tell you all the latest news about Microsoft Azure from the past week in 10 minutes or less. App Service environments provide a premium offering for Azure App Service that offers greater scalability and the ability to deploy to a private virtual network, giving you the benefits of Azure App Service but without exposing your web applications directly to the public internet. This is useful when you want to deploy an application but restrict access to your corporate network only. Version 2 of App Service environments is now available and offers a number of improvements over version 1. When choosing to deploy a new App Service environment, note that the previous version is still available but is now named V1 to make it clear. The new App Service environment is this one, without the version number. When you select an ASE, this dialog will show, which confirms which version of ASE you're about to deploy. Initial deployment is straightforward, with a name needed for the new ASE, a resource group, then select from an existing or create a new virtual network into which your ASE will be deployed. You can choose between internal or external ASEs. If you choose internal, you'll need to provide the subdomain that you plan to use. The pricing details for an ASE are shown here. ASEs take longer than most Azure services to create, but this has significantly improved in version 2. Version 1 can take around 4 hours for a deployment to complete. However, as you can see from this deployment, V2 ASEs are significantly quicker. With an app service, you need to create an app service plan. V1 ASEs had the concept of worker pools, and when you created an app service plan, you had to choose a worker pool. If the pool didn't have enough capacity, you had to create more workers first. With V2 ASEs, the experience is much more like that of a regular app service, and the worker pool is managed for you automatically. In fact, you can start from here at the web app option, exactly the same as you would with a regular app service. You provide a name for your web app and choose a resource group as usual. Then select the app service plan that you want to use, and then select an existing or create a new app service plan. Give the app service plan a name and choose a location, but you'll now see any ASEs you have deployed as available locations for your app service plan, as well as the usual Azure regions. By selecting an ASE, you'll then be able to choose from one of the isolated pricing tiers, starting at 1 core and 3.5 GB of RAM, going up to 4 cores and 14 GB of RAM. V2 ASEs are based on newer DV2 Azure virtual machines, which have faster processors, twice as much memory per core than V1 ASEs, and also feature SSD storage. In fact, you can skip the ASE creation that I showed at the start altogether. Just create a new web app, then when selecting the location, choose an Azure region, and you'll see that the isolated options are available in the portal, along with the usual tier options for app service plans. By choosing one of the isolated options, you'll automatically be prompted to create a brand new ASE. Scaling a V2 app service environment is just as simple as with the regular app service. You can choose the scale up option and select a new tier, or the scale out option and either manually scale between 1 and 100 instances, or enable autoscale and define your autoscaling conditions. New virtual machine offerings are now available in the UK Azure regions. The N series of virtual machines, which feature NVIDIA GPUs, the powerful G and GS series featuring virtual machines with up to 32 cores and 448 GB of memory, the LS series, which is optimized for low latency storage, and the H series, which focuses on compute-intensive workloads and features RDMA network support. If you're a developer working with Azure Data Lake, new online training is available now in the Microsoft Virtual Academy. This free course will take you through an introduction to Azure Data Lake and the Azure Data Lake tools for Visual Studio, SQL programming, batch jobs, performance and optimization, and access control. You can now get Teradata database via the Azure Marketplace. The deployment gives you a choice from 4 tiers, including Developer, which provides free software for application development, Base for low concurrency entry-level data warehouses, Advanced for high concurrency production mixed workloads, and Enterprise for the top-of-the-line offering with sophisticated workload management. The deployment is available for DS14 V2, DS15 V2, and G5 spec virtual machines. The template supports deployment of up to 32 nodes. Azure Functions natively supports a wide range of popular programming languages, but with an extension available via this GitHub repository, you can also run R scripts. Here's an example which shows how to set up a Twitter bot to post a weather temperature forecast for the next 5 days using R and Azure Functions. First, you need to create a new function app, which I'll do through the Azure portal. I'll give the function app a name and choose a resource group. For this demo, an app service plan will be needed, so I'll select and create one of those. Once my function app is created, I'll install the extension needed to run R scripts. So from the Platform Features tab, let's choose the Advanced Tools link that will take me into the Kudu interface. I'll click on Site Extensions, then Gallery, then search for R script. This is the extension I want to install, so let's click the Install button. This takes a couple of minutes to complete. You might see a failure message. If you do, just refresh the page, go to the Installed tab, and check that you can see the R extension. Now go to the Debug console and type rscript-help. help to confirm that the extension is installed. Then I need to complete the setup by unpacking these files using the unzip command. Back to the Functions console, and this time I'll set up a deployment from the GitHub repository that contains the sample code. I click on Deployment Options, then choose Setup, then click here to configure required settings. I'll choose an external repository and then add this URL for the GitHub repository and specify that I want the branch named release-1.0. Now with that set up, let's reload the portal, and now I can see I have a trigger timer function which contains a PowerShell script. That PowerShell script launches the rscript command, passing in the name of the R script to be executed. And this is the R script that will be executed, which will collect weather data via an API, perform some calculations, create a chart, and then post that to Twitter. The function also has a function.json file which defines the triggers that will cause the function to fire. Now I need to set up some API access. I'll go to the Open Weather Map site and get an API key that I can use to retrieve weather data. Then I go to the Twitter developer site. I'll create a new application, give it a name, description, and just put a website name in here. Go to the keys and access tokens page, and I'll need the consumer key and consumer secret. Down here, I need to generate an access token. So I'll click this, and then I need to note the access token and access token secret. Back to the Functions portal, and next I need to add those various API keys to the configuration of my function app. I can do this through the built-in app service editor tool. I'm going to edit the credentials.json file. I'll paste in the consumer key, consumer secret, access token, and access secret information that I obtained from Twitter. Then I need to put the Open Weather Map API key in here, and the script is now ready to run. So let's go for it. The first run may take a few minutes to complete as some R packages will need to be installed, but at the end you can see a message was sent. So let's flip over to my Twitter account, and there's the tweet with my forecast for London for the next 5 days.